Hello everyone. I didn't know whether to call this video studying Bitcoin or how to study Bitcoin with Python. So I think I'll just call it studying Bitcoin. And what we're going to be doing is looking at how you can use Python and certain aspects of Python to help you understand Bitcoin. So without further ado, I just want to bring to your attention a couple of books. So there is a book actually called, if I can find it, Hands-on Bitcoin Programming with Python. Now, I've had a go with this, and whilst there's lots and lots of things in here which you can do with Python to study the blockchain, Bitcoin is not really written in Python, and it doesn't actually, under the bonnet, use much or any Python. So this is a way to help you understand Bitcoin, but not become a Bitcoin developer, shall we say. Today I want to show you and introduce you to Sailor.org. It is a free website for tutorials. If you know Michael Saylor, you will be familiar with his Bitcoin purchases and his company MicroStrategy. He set up this foundation or this not-for-profit website. If you go to Bitcoin for Developers, CS120, I've done a few bits and pieces of it already, but what I want to show you here is Chapter 3, Signatures and Transactions. I've been doing a bit of study around this topic recently, and I just wanted to show you how you can use Python to demonstrate some of the concepts. So let's have a look at, I think it's Chapter 3.3 maybe. Let's try this one. And what we're going to be doing is we're going to look at private keys, public keys, and Bitcoin addresses, and we're going to demonstrate it with Bitcoin module for Python. So hang in there. With each transaction, there's lots of information that gets stored on the blockchain. In particular, something called unspent transaction outputs. There's a graph there showing you how it all happens, how it gets added to the block. When you buy something using Bitcoin, you send an amount larger than what you want to purchase. Then you get back, effectively, you get back some change. So we're going to be looking at how you actually create the signatures and the keys. They are actually the fundamental building blocks of the blockchain. So also, I will just briefly mention script as well, because the script is what does some locking and unlocking, and it's quite interesting. It's based on an old programming language called Forth, and I can actually show you Forth. Forth is very old school. Just exit out of here, clear this, gforth. And if we do 10, 20, and this is a stack, so it's just adding things to the stack. So if we do 30.s, and the stack keeps getting bigger and bigger. And a stack, if you're just familiar with Python, a stack is basically the same as a list, and you've got the same features where you've got push and you've got pop. Anyway, I digress. So we want to go and have a look at the Python example, which, I'll tell you what, rather than me typing it all, let's just go back here. And what you need to do is you need to do pip install Bitcoin. And I've already installed it. Anyway, so then what you do is you import from Bitcoin, import star. And I'm just going to show you what we're going to do is we are going to create a private key. So we'll do my private equals a random key. And once we've got a random key, we could actually print that. So let's do that. You don't have to use iPython. I'm just doing it because it's easier to demonstrate. It saves keep doing print statements. And then once we've got a private key, so the key things here, we need a private key, a public key. So this is asymmetric. If it was symmetric, you would have the person at each end would have identical keys. So if you ever hear asymmetric, it means you've got a public and a private key. And my public key is equal to, and then you convert priv to pub, which is you get that method when you import or install the Bitcoin package. So now we've got a public key. So if we do my public, so the process is you first create a private key, then you create a public key, and from your public key, there's a couple of hashing operations which ultimately give you a Bitcoin address. Your Bitcoin address is a publicly usable address that other people can send, or they can create a transaction to send Bitcoin or parts of a Bitcoin. So just because a Bitcoin is about $19,000 doesn't mean you can't subdivide it. Just like with the dollar, you can send cents, you don't have to send a whole dollar. So right, so we've got a private key, a public key, and now we're going to do an address. We're going to create an address which is, let me just find that for you. There we go. So my Bitcoin, so this is going to generate a Bitcoin address. Pub to ADDR, so public key to a Bitcoin address, and then in the brackets we're just passing in your public key from the line above. Then if we just have a look at that, that is, so it begins with a 1. Bitcoin addresses typically begin with a 1. The more modern ones will begin with 1 BC. This is for demonstration purposes anyway, and obviously this is done in Python, so this is purely for educational purposes. So this was one that I got from a book. Now let me show you the one from Sailor.org. So the Sailor.org one is actually a little bit more accurate, less kind of educational and more realistic. So let's go with this. So you need to install ECDSA, elliptic curve digital signature algorithm. Import signing key and then SECP256 lowercase k1. And you're probably thinking, what the hell is that? Bitcoin SECP256k1. It's the algorithm which Bitcoin uses. If you go on the Bitcoin wiki, you can find as much. So elliptic curve is basically a graph which you use a generator and an initiator, and then it works one way. It can't be reversed. That's the whole beauty of it. So I'll let you read that. I'm not going to pretend to know it inside out just yet. Hopefully one day. The beauty of it is that it creates the number of keys that it can create is more than every atom in the universe. 2 to the 256. So it doesn't sound very much, but every time you go from 2 to the 1 to 2 to the 2, it doubles. So by the time it's doubled for the final time, it's crazy. If you're unsure of the power of exponentiation, read about, there's a story, I don't know if it's true or if it's mythical, about a king who did a deal with somebody when he lost a game of chess. The person who won the game of chess said, okay, how about if I put 1 grain of rice on the first square, and then we keep doubling it, and then however much we get at the end, you give me that rice. When you go from 1 grain on square 1, to the 64th square, so that's to the power of 64, that apparently that's enough rice to put a country as large as India about 10 meters deep in rice. So yeah, exponentiation, just because it's 2 to the 256 does not mean that's a small number. It is enormous. And that's where the security comes from. So you're never going to get duplicate addresses. In theory, you could, but it would probably take a billion trillion years for that to, Right, anyway, so we're looking at Sailor.org, and the example from there, which let's just go back up there, and the first thing we do is they call it a signing key and a verifying key. So the signing key, we do signing key.generate, and then we specify the curve type. So the curve equals SECP, which is what you just saw, the elliptic curve. Actually, let's just look at SK. It will just be some bytes. Okay, so what we want to do next is we'll create a verifying key. And our verifying key is equal to our signing key dot verifying key. Just check we got that. Yeah, so string of bytes. So we've got a signing key, a verifying key, and now we need to actually sign something. So we're going to sign a message. And you just saw what it's going to be there. So signature, and then we'll use our signing key to sign our message. We just use the B there because it's bytes. So signature is equal to that message, and it's signed with our signing key. Then when it gets to the other end, we want to assert that when we use our verifying key, we want to check that when we use the verifying key, the signature is using the verifying key is equal to what we had signed. If it's incorrect, we would get an error message. If it's correct, we'll get nothing. We get nothing. If that message had been altered by even, let's just take that space out of there. So if that had been altered, you see, so this is a very simple example, but if a message gets even altered slightly, then because it's signed, you know when you try and verify it with your verifying key. So the signing key is similar to or akin to the private key. The verifying key is akin to the public key. So you sign messages in private and then you verify them with the public key. Good. So I hope that's kind of given you an appetite or an interest in how Bitcoin works on a really very basic level. I'm still learning this. I just wanted to show you a real basic demo how you can use Python with the Bitcoin module. And here we go with the Bitcoin for developers. Although Bitcoin, the daemon is written in C, it's got a scripting language which is based on gforth, which I just showed you. There are still quite a few examples in here that you can test, run, check out with Python. So I think if you want to brush up on your Python skills, learn a bit of encryption. For instance, if you are a cybersecurity engineer or something, then this would actually teach you quite a lot if you're just starting out from scratch and you want some free learning material. Sailor.org Academy. If you've watched much of YouTube with videos about Bitcoin, you probably know of Michael Saylor, very clever man and very kind to give us this, I think. So yeah, I'll let you go and visit it, have a look around, do some demos, and some of the chapters have got videos, so you can watch away until on that note, see you next time.